keyboard interface to the processor with the help of parallel board. Now I am going to discuss about printer interface to the processor with the help of parallel board. Okay. Now look at this. We are all very well known that input devices are keyboard, mouse, all those things are examples of the input devices. Printers as well as monitors as well as LEDs, LCDs, all these are coming under the examples of output devices. In this case, I am going to interface printer, which is nothing but an output device, that I am going to interface with the computer by using parallel board. Now say this one, this is my processor and this is my output device, which is nothing but the printer. Before I am going to establish the communication between the processor and printer, I am going to consider some of the assumptions. The first one is my processor is a 32-bit processor. Is it? I am assuming my processor is a 32-bit processor. What it means? That means it can accept the 32-bit of data at a time. That is the first assumption I am considering for that establishing the communication between the processor and the printer. The second one is whenever we are going to address any device to the processor or to the computer, we may be used any one of the two schemes for addressing the device. Okay, one is memory mapped input output, memory mapped input output, and the second one is input output mapped or isolated input output mapped. Here I am considering the memory mapped input output. I told you the instructions how you are going to access the data whenever we are considering the memory mapped input output. Similarly, I told you the instructions which we are using for accessing the data whenever the data is placed in the input output mapped memory. Okay, but here we are considering the memory mapped input output address scheme for assigning the address to the input output device. Here we are considering the output device. Next, very important one is the third one. I am going to assume asynchronous protocol. Okay, mainly we are having two types of bus protocols while we are transferring the data through bus. What are they? They are, first one is synchronous bus protocol and the second one is asynchronous bus protocol. But in this case, while I am transferring the data to the bus, I am using the asynchronous protocol. These are the assumptions I am considering before I am establishing the connection in between the processor and the printer. Now look at this. Whenever the processor wants to communicate any device, whether it may be the input device or whether it may be output device, whenever it is going to communicate the input output device, first it should assign the address to that device. So my first step is the processor needs to assign the address with the help of address lines. Okay. Second one, we need to know about what type of operation we are going to be performed. Previous case, I told you the input operation. At that time, we consider the input device as a keyboard. Now, I am going to consider output operation, which is nothing but write operation. Input operation means read operation. Output operation means write operation. So my second step is read slash write bar is equal to 0. That means here we are going to perform the write operation. Okay. So in case of read operation, what the processor does. In case of write operation, what the processor does or what the processor has to be performed to perform output operation, or what processor do when the read operation is performing. Here, first consider read operation. Whenever the read operation is performing, the addressed slave device places the data on the bus so that the processor reads the data from the bus into its input buffer register with the help of interface circuit. Okay, so that is a read operation. Now we are going to perform here write operation. Whenever we are performing the write operation, processor places the data on the bus, and then the data on the bus should be grabbed by the output device with the help of interface circuit. So here it is output operation. So it will be treated as write operation. Input operation means read operation. So write operation. Now this is the write operation. So first processor has to assign the address to the slave device. Next, processor has to inform to the slave device with the help of control signal read/write bar is equal to 0, so that it can be identified the write operation is going to be performed. Next, the third important step is data is placed on the data bus. See my dear friends, here the direction is towards the processor, but it is wrong. The direction is towards the printer. See, my first step is address should be assigned to the slave device. Second step is what type of operation we are going to be performed, that is read or write operation. Here we are performing the write operation. Third step is the processor places the data on the data bus. And my fourth step is once the processor is ready to participate in the data transfer, then it informs to the slave device while accepting the master ready signal. With the help of master ready signal, the processor informs to the slave device the processor is ready to participate in the data transfer. This is my fourth step. Once the slave devices are identified, the processor is participating in the data transfer, then the addressed slave device has to grab the information from the bus into the printer. Okay, further, the next step is data. So, see how the data will be coming to here, from the data bus to here. We are not directly connecting the output devices to the processor. We are connecting the output devices to the processor with the help of interface circuit. Interface circuit contains so many number of resistors. While I am discussing about the input operation, I told you that your input circuit, your interface circuit contains data in resistor and S in 1-bit resistor. But here your output interfacing circuit contains data out resistor as well as 1-bit S out resistor also. Okay. Now once the processor informs to the slave devices, I am participating in the data transfer with the help of master ready signal, then the data will be transferred into the data out register. Okay, so this S out signal is useful to identify whether the data is placed in the data out register or not. Okay, suppose if S out is equal to 1, then it can be identified, that is the printer identified the data is available in the data out register. Once the data is transferred out from the data out to the printer, then S out will becomes 0. Then the processor identifies there is no data in the data out register. Similarly, the printer is also identified. There is no data present in the data out register. So, data out and S out registers are inside the output interface circuit. Okay. Now, whatever the data placed on the data bus by the master, first it should be received by the output interface circuit and then it will be go to the data bus. Okay, this is my fifth step. Next, printer wants to receive the data from the data bus. Before that, printer has to know whether the data is valid data or not. So, this is my sixth step. Once it is the valid data, then the printer grabs the data from the data bus and it will be displayed on the printer. Once the data is displayed on the printer, then the printer informs to the processor with the help of ideal signal. This is seventh one. First, the printer informs to the interface circuit with the help of ideal signal. That means the data is displayed on the printer and there is no data available in the data out register also. Okay. Next, the output interface circuit informs to the processor by accepting the slave ready signal, that is the printer is finished its operation. Then the processor sends another data into the data out register. Before it is transferring the data into the data out register, the processor needs to check the S out bit. If S out is equal to 0, then the processor identifies there is no data present in the data out register so that it can be transferred the data into the data out register. Once the data is placed on the data out register, then the processor finishes its operation. Okay, and it informs to the slave with the help of master ready signal. Okay, this is the way we are going to perform the communication in between the output devices to the processor by using the parallel interface operation. Okay, and the next one is this is the very important thing. This is nothing but output interface circuit. Internal output interface circuit. Now listen clearly how the internal operation is going to be performed. Okay. Now see this one. I am assuming the processor generated address is 32-bit. The processor generated address is 32-bit address. Out of those 32 lines, the processor is used only 31 lines for assigning the address and the remaining line that will be used to transfer the data or it may be used to read the status. That can be identified with the help of A0 bit. So, whenever we are performing the output operation, first the processor assigns the address to the slave device. Whenever it is assigning the address to the slave device, out of 32 lines, the processor only uses the 31 lines for assigning the address and the A0 address bit that will be used to identify whether the data is transferred to the printer or we are going to read the status information. That will be identified with the A0 bit. Okay. Always we are assuming that the address decoder output is equal to 1 and that will be applied to here. Similarly, it will be applied to here also. Now look at this. After assigning the address, what the processor do? Processor is informs to the slave device whether it is going to perform the read operation or the write operation. Here we are going to perform the write operation. So read by W bar is equal to 0. If it is 0, that means here this signal will be connected to here, this becomes 0 and this will be goes to here and it will becomes 1. Okay, so first the address is assigned and then the processor is informed to the slave device what type of operation is going to be performed. Okay, next the processor after performing these two operations and informs to the slave device by accepting the master ready signal. Once the master ready signal is accepted by the processor, then the slave devices are identified. The master is participating in the data transfer. So this is also treated as a 1 and this is also treated as a 1. Okay. Finally, we have only one bit which is nothing but the A0 bit. This is the important bit. With this bit, we can identify whether the data is transferred to the output device or we are going to read the status of the data. Okay. So, suppose if it is equal to 1, then what happens? This 1 will be applied to here and it will become 0 and this 0 will be goes to here and this 1 will be goes to here. Okay. Now, look at this my friends. This is AND gate 1 and this is AND gate 2. One of the input of the AND gate is 0. Obviously, the output of the AND gate will become 0. If you observe here, there are two inputs that becomes 0 and obviously the output of the AND gate is also equal to 0. Once it is 0, then it will be disabled. Now, all the inputs are 1s and then obviously the output will become 1 and this will be applied to the data out resistor and this is act as an enable signal as well as it act as a clock to the data out resistor. Okay, now this one will be applied as one input, now it becomes 1 and this one will become 0. Okay. OR gate, one of the input is 0, no problem at all. If one of the input will becomes 1, then obviously the output will becomes 1. Now, the 1 will be applied here. We are all very well known that the tri-state buffer performs 3 operations. One is input and the other one is output and this one is enable signal. And now this one will be connected to here. Now this is active and the default input to this tri-state buffer is 1, then the slave ready is activated. Okay now look at this. Once it is equal to 1, then this data out register is operated. That is, the data placed on the data lines will be transferred to the data out register. From that, the data will be transferred out to the printer. It contains so many number of, suppose it is an 8-bit register, it contains 8 drivers. Those drivers are operated with the help of this enable signal. Okay now look at this. This is the way we are transferring the data from processor to the output device, that is printer in this case. Okay, now there is a second option also. What is that? We may read the status information also. Now this bit becomes 0, remaining all are same. Okay, now it is 0, it becomes 1, now it becomes 1. Okay, now it becomes 0. Okay, now look at this. Here we are not going to perform the read operation. Write operation. We are going to perform the read operation. Then why? Because we are going to read the status of the data out register. That's why read operation. So that is equal to 1. So now this becomes 1 and this becomes 0. So obviously the output of the first AND gate will becomes 1 and the output of the second gate will becomes 0. Whenever it is 0, then the data out register is disabled. Okay, that means it may not transfer the data to the printer. Okay, now it is 1, it will be activated. Okay, here we are using the two control signals. One is ideal signal and the other one is valid signals. Okay, so this one will becomes 1 Now, so handshake control generates one output, that is S out signal, that will becomes 1. Okay, so that we may read the status of the information. Whenever this one will becomes 1 and this one will becomes 1, the output is activated, so we may read the status. Okay, whether it may contains the data or not. Likewise, we can perform the write operation as well as we can perform the status of the read operation also. This is about the output interface circuit. Okay. Next, coming to the next one is internal structure of the interface circuit. Till now we have seen it that two different types of interface circuits. For the case of input operation, we have seen it that input interface circuit, and for the second case we have seen it that output interface circuit. In case of input interface circuit, the interface circuit contains what type of resistors? Data in register as well as S in register. In case of output interface circuit, it may contains data out register and S out registers. Okay, now we are combinedly looking at the internal structure of interface circuit, that is for both input and output. For both input and output, that is the internal structure of interface circuit, combined input and output operations. Okay, now see this one. This is my combined internal architecture of input and output interface circuit. If you observe the things, whatever the things we observed in the previous cases, the same blocks will be occurring here also. Okay, now look at this. This is the address decoder. The address decoder is used to assigning the address, that is decoding the address, so that the appropriate slave device will be detecting that address. Master ready signal, that is used to identify whether the master is participating in the data transfer or not. Read write signal, whether it is the read operation or write operation, that can be identified with the read write signal. Okay, now see this one. These two bits are important in this case. While we are discussing individually about the internal interface circuits, out of 32 bits, we have used 31 bits for assigning the address, and 1 bit is used for read the status information, as well as it can receive the data. In case of read operation, it can send the data to the printer. In case of write operation, that can be identified with the help of this 1 bit. Whereas in case of the combined internal interface circuit, we are using 30 bits for assigning the address, and these 2 bits are used to identify whether it is the input operation. Okay, that means it may receive the data to the processor unit from the peripheral device, or it may transfer the data to the output device from the processor. That can be identified with the help of these 2 bits, A0 and A1. Always the address decoder is equal to 1. Okay, here I am assuming, okay, out of input and output operations, I am assuming the processor is going to perform the read operation. So read by W bar is equal to 1. So this becomes 1. As well as the same signal will be applied here. This will becomes 1, and read write signal is applied here. This is 1, and this is also 1. Okay. Now the address will be transferred to here also. This one will becomes 1, and here the master ready signal. Okay. Here it is 1. Obviously 0, and it will becomes 0. Okay. Next, coming to the read write signal, that is 0. Next, master ready signal. Master ready is directly applied to all the 3 AND gates. Okay, without any inverter. This is 1, this is 1, as well as this is also 1. Okay, now look at this. If you observe this, here we are having RS1 and RS0. RS means resistor select. Here you have so many types of resistors. One is data in resistor, other one is data out resistor, input status bit, that is S in, output status, that is S out. Okay, like that we have so many types of resistors. Those resistors should be identified with the help of these two bits. Okay, so that the processor clearly identifies whether it is going to be perform the input operation or whether it is going to be perform the output operation. In case of input operation, that is read operation, the resistors are, one is data in resistor and the other one is S in resistor should be selected. In case of output operation, one is data out resistor and the other one is S out resistor should be selected. With the help of that, the processor identifies what type of operation is going to be performed also. So these two bits are like that. Here I am considering A0 and A1 is equal to 0, 0. 0, 0 means it is 0. The 0 will be connected to here and it is 0. Here it is 0, 0 means here it is 1, this one will be connected to here, okay, and this one is also connected to here. Now this is 0, 0 means down one will be connected, here it is 1 and here it is directly connected, it is 0, okay, here it is 0. Now here we are getting the output as 1. Okay, and here we are getting the output as 0 and here we are also getting the output as 0. One of the indicator input is equal to 0, obviously the output is equal to 0. Here the output is 1, so this one will be connected to here. So this is a tri-state buffer, that too this is S in a 1-bit resistor and this will be used to read the status information. Whenever Sn is equal to 1, okay, that identifies there is the data present in the data bus. Okay, so this is the way we are going to perform the input operation. See my friends, here we are having 8 separate input lines for the input operation. We are having 8 separate output lines for the output operation. Yes or no? Here these lines will be used to perform the input operation and these lines will be performed to perform the output operation. Okay, likewise, if the combination of the bits are changing to 0, 0, 0, 1, 1, 0, 1, 1, here you read the status information, here you may perform the read operation, that means the data will be received, here you may perform the read operation and here you may perform the write operation. That will be depending upon, okay, these two bits, okay, so that the processor can identify whether it may perform the read operation or write operation. This is the combined parallel interface circuits to communication in between the processor and the devices, slave devices. This is the combined circuit. This is the parallel circuit. Okay, here we are having 8 input lines, here also we are having 8 input lines. All these things I discussed in the previous cases also individually. But out of all the operations here, depending upon these bits, it may perform the read, status information, it may perform the data receive operation, it may perform the status of output data, it may perform the transfer the data to the printer. That will be depend upon these two bits, A0 and A1. Remaining 30 bits are used for assigning the address. Okay, this is the way we are discussing about the internal structure of the parallel interface circuit. Okay, next, coming to the case of combined input-output interface. Just now only I discussed about this. Okay, same thing I discussed just now also. Just always assume the address of the decoder is 1. If it is a read, it is 1. If it is a write, then it is 0. Suppose if it is a write, it is 0. 0 means it becomes 1. It is 1 and here it is 0, it is 0. Write operation. Write operation means processor transfers the data to the printer. If write operation is performed, then obviously the output will become 1. Then the data will be transferred from the data out register to the printer. Okay. So while you are selecting the data to these lines, take care. Okay. Next, coming to the parallel general purpose parallel interface. Previous case we have seen that it consists of separate input lines and it consists of separate output lines. Then obviously the cost of the device is also increases. The input output interface circuit cost is also increases. To reduce that, here we are using only 8 lines. For those 8 lines will be used for both serial operation, for both input operation as well as output operation. Okay, see this one here. These on to D7 are used for the data lines. Okay, and you are all very well known that the data out register is used to hold the data which the processor wants to transfer to the printer. Data in register is used to hold the data while the processor is receiving the data from the peripheral devices to the processor. Now look at this. This is the register select. These 3 are the register selection bits RS0, RS1 and RS2. By using those 3 register selection bits, one of the register will be selected during the operation. And this is the read and write operation. With the help of read and write operation, the processor identifies what type of operation is going to be performed. And there are 2 handshaking signal. One is ready signal and the other one is accept signal. Ready signal is act as master ready. Okay, ready signal is act as master ready, as well as accept signal is act as slave ready signal, and this is the address. Okay, next, see this one. Here we are having a separate register which is nothing but data direction register, which is called as DDR, data direction register. Here it is assume that here it is an 8-bit register. Why? Because we are using 8 lines for transferring the data. Okay, so this direction register content is used to identify whether you are going to perform the output operation or whether you are going to perform the input operation. If the content of these bits are all zeros, then this will be connected as an enable input of the tri-state buffer. If all are zeros, that means no data will be transferred from the data out register to the data lines. That is the print from the data line goes to the printer. But here, if all the 8 bits are 0, then it disables the drivers so that no information will be goes to the printer. If all the bits are equal to 1, then all the drivers or tri-state buffers are activated so that the data in the data out will be transferred out. Okay now. So the inputs to the data direction register is applied from the data lines. With this, it can be identified whether the data will be transferred or not. Okay. So generally the input register is used to receive the data from the slave data in the register, from the slave devices to the data in the register. Once the driver circuits are activated, then the data will be accepted into the input buffer, into the processor register. And these 2 are the control signals. Okay, status and control signals that are M1 and M0. Okay, this is the modified combined input output parallel interface circuit. It is its cost is less and it has less number of interconnections when comparing with the previous case. Okay, next coming to the serial port. Previous class I told you that whenever we are transferring the data from the peripheral devices to the processor, we may use serial communication or we may use the parallel communication. Generally, the data coming from the peripheral devices are always in the serial form. Okay. Once the data is entered into the input register, that is an interface circuit, then it will be converted that serial to parallel. From the interface circuit, the data will be transferred to the computer is in the form of parallel. Now look at this. Here we are going to discuss about the serial port. Previous case I discussed about the parallel port. Okay, these two things are very important. Why we are going to transfer the data from processor to the peripheral devices or from the peripheral devices to the processor. Coming to the serial port, it is used to connect an input-output device to the processor, which transfers as well as receives the data bit by bit. Why? Because it is a serial port. It may not contain so many number of connections like what we have seen in the serial parallel port operation. Parallel port contains multi-bit connector. So because of the multi-bit connector, it receives so many number of data at a time, depending upon the number of cables we are using. Okay, but this is the serial port. The data will be transferred to the processor bit by bit only. Serial port communicates in serial form in input devices side and parallel form to the processor side. Generally, the peripheral devices are placed far away from the processor, so that we are going to be using the serial port communication. So from the slave devices to the one end of the processor is coming in the form of serial, and from the interface circuit other end to the processor is parallel. The conversion of serial to parallel is performed in the interface circuit. Here it is represented. Transformation between the parallel and the serial format is achieved with the help of shift registers. Those shift registers are placed inside the interface circuit. Okay, now they are in the interface circuits. Next one is, this is the block diagram of serial port. Okay, here it is the combined block diagram of the serial port for the accepting the data as well as sending the data out. Now this is the input shift register. The input shift register accepts the data. Listen carefully. The input shift register accepts the data serially, that is bit by bit. The data is coming from the peripheral devices to the shift register of the interface circuit is bit by bit. That is serially the data is loaded into the input shift register, and then the data in the shift register is transferred parallelly to the data in register, because the input shift register converts the serial data into the parallel form, so that whatever the data which is loaded into the input shift register, okay, that will be transferred parallelly to the data in the register. Okay, now the data in register data will be received by the processor with the help of data lines. So whatever the data in the data in, that will be received by the processor parallelly. Okay, that is 8 lines. Okay, now this is the chip and the register selected. Previous place also we have seen that there are 3 register selection lines, but here we are having 2 register selection lines, RS0 and RS1. Whenever the processor wants to communicate with any peripheral device, first of all it has to assign the address. That address will be assigned with the help of these address lines. Now, whether it is the read operation or write operation, in case of input it is the read operation, in case of output it is the write operation. That can be identified with the help of read/write bar. Here these two are the handshaking signals, ready and accept. Ready means that is master ready. Accept means that is slave ready signal. These are all the operations of the resistors. Now, if it is a read operation, then R by W bar is equal to 1. Then the processor reads the data parallelly from the interface circuits to the processor register. Suppose processor wants to transfer the data out from the processor to the printer. Then what happened? The write operation is going to be performed. R by W bar is equal to 0. At that time, initially the data in the data bus is transferred to the data out register parallelly. Why? Because this end is at the processor side. Processor side is in the parallel form. So the data entered into the data out register is parallelly. Okay. Then from the data out to the output shift register is also in parallel form. Once the data is entered into the output shift register, okay, then there is a conversion is happening from parallel to the serial form. Then the data will be sending out serially, that is bit by bit. So in case of write operation, what is going to be happen? The data is initially coming to the interface circuit registers parallelly, and then it will be entered into the data output through output shift register. Once the data is entered into the output shift register, the data will be converted from parallel to serial, and then the data will be sending out bit by bit through the serial out register, serial out pin. Okay, and once the operation is completed, and it can be informed to the processor with the help of interrupt signal. Okay. This is the way we are going to perform the input operation as well as output operation by using the serial port. Previous case we have seen the parallel port. Now we have seen the serial port operation. Okay. Next, see this one. Already I told you that the shift registers are used. Why we are using the shift register? In this case, the shift registers are used to convert the data from parallel to the serial as well as serial to the parallel. The input shift registers can start receiving set of 8 bits from the input device. After loading the contents to the data in, before the processor reads the content of data in, this is called as a doubling buffer. See my dear friends, here this doubling buffer is the data is entered into the data in register, okay, to the input shift register parallelly. But while the data is receiving into the input shift register, it receives the data serially. Here the serial to parallel conversion is happening, and then the data will be entered into the data in register. Whatever the data in the data in register, that should be read by the processor. Okay, but before reading the processor, if another data is coming, before the processor reads the data in the data in buffer register, if the peripheral device transfer another data in the data in register, then that is called as doubling buffering. That means the data in the data input register is not read by the or not received by the processor. Before it is receiving the data to the processor, another new data is entering into the data in register, then we are calling it as doubling buffering. Okay, the speed of the transmission of the data rate in the serial interface is known as bit rate. Depending upon the bit rate, the speed of the operation is performed. If the bit rate, that is the number of bits transmitted per second is high, then the data transfer is high. If the number of transmitted bits per the second is low, then the data transfer rate is low. Okay, that is about the bit rate. Coming to the last one. In order to accommodate the devices with a range of speeds, a serial interface must be able to use a range of of clock speeds. Okay, see my dear friends, here you are having two clocks. One is a receiving clock and the other one is a transmitting clock. With the help of a transmitting clock, the data will be transmitted. With the speed of the receiving clock, the data will be received. So, see this point. In order to accommodate devices with a range of speeds, the serial interface must be able to use a range of clock of speeds. That is, the transmitter clock is have one speed, receiver clock is have another speed. So, in order to accommodate variable number of devices, we have to use the variable clock speeds. Okay. Several standard serial input-output interfaces are there. One is UART, that is Universal Asynchronous Receiver and Transmitter. There, the bit speed is very low. Okay, that will be used in the serial port operation. Now coming to the RS-232 for the communication to the communication links. There, the bit rate is high, so the data transmission rate is high. In this case, the data transmission rate is low, and in this case, the data transmission rate is very high. These two are the examples of serial communication. Okay, interface circuits. One is UART and the other one is RS-232C. So, you understand about the interface circuit. But listen carefully. Once again, go through the combined interface circuit. Before going to read about the combined interface circuit, first of all you have to go through the individual parallel interface circuits, that is for the input as well as for the output. Once you get the clear idea regarding to this, then you can clearly understand about the combined interface circuit. Thank you everyone for the patient listening.